All right, we're going to take a look at now a proof that involves some parallel lines, given lines parallel, and we're going to try and prove something about angle 1 and angle 4. So as we look at this diagram, we've got a bunch of sets of parallel lines. We're trying to get from angle 1 down to angle 4. There's not a direct relationship there. By direct relationship, I mean we can't make the F to get corresponding angles congruent. We can't make the Z to get a pair of alternate triangles congruent. We can't make the C to get same side triangles supplementary. So it makes sense that we want to start up at angle 1, work our way here, work our way down, work our way across, and somehow tie all that stuff together. So we're going to start off with, again, 99% of the time we start off with the what? The given. Exactly. I'm going to write given up there. I'm going to write A parallel to B parallel to C, B parallel to E. And remember, when we're given parallel lines, that's when we can use parallel lines imply something. So in this case, I'm going to say, all right, parallel lines imply, and let's look at angle 1. If I look at angle 1, can I make a relationship with angle 2? So if we were to highlight angles 1 and 2, it makes that Z shape. I don't know if you can pick that up on the screen, but it makes that Z shape. So angle 1 and 2 are going to be equal to each other. How do we know that? Well, parallel lines tell us that when we have that Z shape, it's alternate interior angles. Alternate interior angles congruent. Now I got to say, how can I get from angle 2 down to angle 3? If I were to trace over those angles, that makes the F shape. Those are corresponding angles. Now I can say, all right, angle 3. Whoops. Start over. Angle 2 equals angle 3. Reason for that, parallel lines imply corresponding angles congruent. So now I've got 1 congruent to 2, 2 congruent to 3. I can get 3 over to 5 with the same reason, right? I'm going to write right below that, angle 3 equal to angle 5. That's another pair of corresponding angles. Now, can I make a relationship between 4 and 5? Not with the parallel lines, but they make the X. What kind of angles make the X? Vertical angles. So what do we know is true about vertical angles? They're congruent. So I can say angle 5 equals angle 4. Reason? Vertical angles congruent. Now don't make the mistake. I always see kids do this all the time. They want to write definition of vertical angles. It's not the definition of vertical angles that they're equal. It's a theorem that we actually proved. We showed why vertical angles are equal. So now I've got angle 5 equal to angle 4. Now what can I do with all this stuff? Now we could have along the line, we could have said 1 equals 2, 2 equals 3, substitute 1 equals 3. Then we could have said 3 equals 5, substitute 1 equals 5. Then we could say 5 equals 4, substitute 1 equals 4. But the way we set this up, if I was going to do substitution, I'd have to do substitution at least twice. Because I could look at this line and say I could substitute a 1 in here and a 5 in there, and then I could substitute a 4 for angle 5. But the way we have this set up is to use the transitive property. If you remember the transitive property, if this one ends in something and the next equation starts with that, this one ends in angle 3, the next one starts with that, this one ends in angle 5, the next one starts with that, I can go right from the beginning to the end. It's that train property, the transitive. They're all connected together. I can get from the engine to the caboose in one shot. This is going to be the transitive property. And now I can get angle 1 equal to angle 4. So if you look at that, we've got a proof set up. This is not a very difficult proof, but a couple sets of parallel lines. Should definitely be able to get from one line down to another fairly easy. Adding in an extra one, it's just a few more steps. But let me erase this, and then we're going to take a look at one that involves some angle bisectors. Now, I know you're not used to seeing this. You're used to seeing me in videos, being in my basement, the Jarvis downstairs, kids running around, fire in the background. I'm here at the boring whiteboard. We're in school, but that's okay. It is Movember, right? So if there's one thing I learned, never shoot a video during the month of Movember. This stuff's killing me. It gets chopped off in a few weeks. All right, let's take a look now at a problem where we're going to prove a set of lines parallel. So this is now a case of I have to try and find a pair of corresponding angles, show that they're equal to each other, and then I can say they're parallel using, we had a postulate and 2 theorems. Corresponding angles congruent, give us parallel lines. alternate interior angles congruent, give us parallel lines, and same side interior angles supplementary, meaning the two angles that up to 180, give us parallel lines. So now as I look at this, I'm trying to show BC is parallel to AD. So again, you got your highlighter. I know Olivia's got one if somebody needs to borrow one, because she seems to always have at least one or 10 on her. But sort of highlight the lines that we're trying to show parallel, and then see, can you get any of those shapes? Can you get the F, corresponding angles? Can you get a Z, alternate interior angles? Can you get the C, same side interior angles? In this case, I could get a C, but it doesn't have anything to do with the numbered angles. If I go this way, it does give me that Z. So now, I've got the Z going on this way. If I could show that angle 2 equals angle 3, I could say the lines are parallel. And it would make sense to go that route because I already know 2 equals 4. If I could show 2 equals 3, I'm done. If I can get that 4 to turn into a 3, we're done. So what do we know from the given? Angle 2 equals angle 4. BD bisects an angle. Again, when you see an angle bisector, it should be like, whoop, whoop, whoop. Definition of angle bisector is going to give us 2 equal angles. My whistle today is pretty bad. That's what happens when you do these videos at the end of the day. Your voice is usually shot, and you're ready to go home, which I will be shortly. Well, let's take a look at this. What do we start off with? Everybody says? Why doesn't anybody say anything? I'm in a classroom with nobody in here. But anyway, everybody would say the given, right? 99% of the time. We go angle 2 equals angle 4. BD bisects angle ABC. Once I have an angle bisector in there, it should be like, again, bam. Got to use the definition of an angle bisector. That's telling me something. So if I'm using the definition of an angle bisector, what does an angle bisector do? It divides an angle into 2 congruent angles. Now it's dividing angle ADC. It splits this angle into 2 equal parts, namely angle 3 and angle 4. So I can say angle 3 equals angle 4. Now I go back to the given. I had 2 equals 4. Now I know 3 equals 4. I can substitute angle 3 in place of angle 4 in that equation. So now that's going to give me angle 2 equals angle 3. What did we just do? Substitution. And now what kind of angles are 2 and 3? They are alternate interior angles. Are they equal? We just showed that they're equal. So now I can use that theorem that says if I've got a pair of alternate interior angles that are congruent, equal in measure, then that's got to give me 2 parallel lines. And the 2 parallel lines it's going to give me are BC, segment BC, parallel to segment AD. So there's an example of trying to prove a set of lines parallel. Alright, this problem is going to be hard to do. They've enacted the force field and we cannot get into the problem until we turn the force field off. And it's off. Okay, now we can start. This is one of those problems, and I got to be quick because my battery's about to die on the laptop here, but this is one of those problems that could be a little involved because I'm given parallel lines and I'm also trying to prove a different set are parallel. AB is parallel to DC. Let's mark that off in our diagram. Again, if I look at these lines being parallel, I got a C, same side interior. I got a Z. I've got a Z, so I got 2 pairs of alternate interiors over here. I do know angle 2 equals angle 6. I'm trying to prove these lines parallel. If you look at these lines being parallel, it's like I got an F going that way. I got an F going that way. If I did the F going this way, that would be angles 1 and 5. If I did the F going this way, it would be angles 2 and 4. And it should be like, hey, let's do 2 and 4 since I already know 2 equals 6. So we're going to start off with, again, I don't know how you guys know this all the time, but we're going to start off with the given. AB parallel to DC, angle 2 equal to angle 6. Now, I've got to use those parallel lines. If I'm given parallel lines, I know I'm going to use parallel lines to imply something. So I should either use these parallel lines to tell me something about angle 2, or use these parallel lines to tell me something about angle 6. And guess what we got here? The infamous Z. Angle 6 and angle 4 then have to be equal to each other. Why? Parallel lines give me alternate interior angles congruent. Next up, 2 equals 6, 6 equals 4. What can I do with those two? Substitute in, because that's going to tell me angle 2 equals angle 4. And all we're doing is taking that, substituting it in place of angle 6. Substitution. Now, what kind of angles are 2 and 4? 2 and 4 are corresponding angles. We just showed that they're equal, so can we now say that they're parallel? We can. We can say AD parallel to BC, and the reason's going to be corresponding angles, congruent, imply parallel lines. It looks like I'm just going to sneak this in because the computer's about to shut off, but hopefully you'll do well on tomorrow's test, and hopefully these videos helped you out.